functional groups do we have present? Let's circle those and annotate those. This guy right there, what do we have? What functional group? Aldehyde. Okay, we have an aldehyde right there. What about this guy right there? Alkene. Ester. Thiol. Benzene. Everyone knows that one. Amine. Carboxylic acid. Alcohol. What about that guy? Acid anhydride. We have another alcohol right there. What's this guy? Amine. Ketone. Alkyne. Amide. And that one, sulfide. Okay, pretty straightforward, right? Well, once you know straightforward once you have these in your brain, right? Getting it there takes some effort and some time. I understand that. Okay, so annotating that. You're going to have the video of this so you can double check that. Okay, then what are the hybridization states? Let's see, what's the hybridization state of this oxygen right here? sp2, because we have 1, 2, 3 groups around it. That makes it sp2. This carbon right here, how many groups are attached to it? Electronic groups. 1, 2, 3. So that is sp2. What about this carbon right there? SP? Okay, we have SP, sp2. Anyone want to call it sp3? So what is it? sp2. There's 2 electron groups around, or 3 electron groups around it. Do you see them? No, they're not there. You can't see them until you draw them in. Right? We have a hydrogen and a hydrogen. So we have that electron group, that one, and that one. So that carbon has 3 electron groups. That makes that sp2 hybridized. Do you see that? You have to watch your organic chemists now. You have to visualize in your mind's eye those hydrogens that are hiding. You can't just say, oh, hydrogens, they don't count. Yeah, they have electrons. It's going to have an electron group. You have to have electrons in an orbital for those hydrogens to form a bond. So the hybridization state has to match up. What's the hybridization state of this carbon right here? sp, because you have the triple bond and then the single bond on the other side of it. There's only 2 groups, so that's sp. Now this alcohol right here, what's its hybridization state? Say it with some confidence, people. What is it? sp3. You remember, did I make fun of you guys? Like, can you guys count to 4? Because that's all we have to do, right? Let's just count to 4. What? We have a lone pair there. We have a lone pair there. And we have a hydrogen. So 1 group, 2 group, 3 group, 4 groups. sp3. Okay, you see? The concept of counting is easy. It's just, you guys need to remember how many lone pairs are there. Where's the hidden hydrogens? That's kind of the tricky part. And then, is that all the arrows? I think it is. But could you, in theory, figure out the hybridization state for every single atom in this molecule? Yes, and I would expect you to be able to do that. So that might be good homework. Take that molecule and look at all the atoms, and if you want some confirmation, if you did it right, post it in the discussion forum and let ULAs answer your questions. All right? I will make this observation from last semester. The students in last semester, they were dumping question after question after question into those discussion forums. You guys are taking a whole lot longer to get going. Okay? So there's no stigma, no shame, no glory. Just start getting your questions in there, getting them answered. Okay? Start working on problem sets. Make up your own problem sets and let the ULAs help you guide you through it, okay? So please use that. What are the degrees of the alcohols and the amines? So now this is applying. I've already taught you the lesson. Now you have to apply it. Here's our alcohol. What type of alcohol is that? That's primary. What about this guy? That's secondary. What about this amine right there? That is also secondary. And then this guy, that's primary. Is this an alcohol? No, that's a carboxylic acid. Any questions on that problem there? Okay, so let's add some others here. So draw the skeletal structure for this condensed formula. So I'm going to give you two problems where I'm giving you a condensed formula. So take that condensed formula, draw the skeletal structure. There's two of them actually. And then for the second problem, do the same thing. I want a skeletal structure. In question 3, oftentimes students will only learn the concept in one direction and not in the reverse direction. What do I mean by that? I want you to take this problem, okay, right here. Take that problem, that zigzag, and convert it into a condensed formula. So work on those 3, and I'm going to add a 4th one because I'm feeling really nice today. So what is the hybridization state of that carbon that arrow is pointing to?